Question 2. Mr. Adams takes a trip to an amusement park and rides a Ferris wheel. The graph below shows the height and feet above the ground of his car over time t, measured in seconds. So down here we have the number of seconds he's been riding for, and over here we have the height in feet above ground. So it looks like this graph, he starts at the lowest point of the Ferris wheel, which would make sense because he's getting in the car. And then over time, the height of the Ferris wheel goes up and then goes down. He's back to where he started, goes up and goes down. And they want to know an equation in terms of y, which is the height in feet above the ground, and t, which is the time in seconds to represent this problem. So we know our equation is going to be y equals. To write the equation of a graph like this, we need to know if it's sine or cosine. Remember, sine starts at the midline, and cosine starts at the highest or lowest point. So this is a cosine graph. To write an equation, we need to know what the midline is. So I noticed that the midline is kind of going to have the minimum and the maximum look like they're in spots that are hard to tell on the y-axis, but they gave us these points to show to make it easier for us. So the 42 here is the highest value and the 6 is the lowest value here. So if I do 42 minus 6, we get 36. That's the distance between the lowest point and the highest point. And I need to cut that in half, which is 18. The 18 is going to tell us how tall this graph is. Remember, amplitude is the measure of the distance between the middle of the graph and the top of the graph. We don't measure height of these graphs from bottom to top. We measure it from middle to top. So this 18 is going to actually go right here. This 18 is going to help us find the midline. If the lowest value here is 6 and the highest value is 42, we need the number halfway between that. So to get the number halfway between that, we would just need to add 18 this way or subtract 18 this way, and we'll get the same number going in either direction. We'll get 24 is the midline, which would be like roughly right here. And that looks pretty close to being the midline. So remember, the midline goes right here. We put an X in the parentheses. The last value we need is we need to find the number. We call this number B. And this number, to find this number, it's 2 pi divided by where does this graph finish its first full cycle, which is called the period. So 2 pi divided by where it finishes its full cycle. It finishes its full cycle right there. It finishes at 40. So 2 pi over 40 is going to go in that spot. I'm going to reduce it just because that would look better. So that'd be pi over 20x. And then part 2 of this graph says, if the ride operator increases the speed of the Ferris wheel after 120 seconds of running it, would this change the graph's amplitude, midline, or frequency? So the speed of the graph, if we were to change the speed, that means the number of waves we're going to see is going to go up. And making these waves compress or expand, that's going to be the graph's frequency, right? The midline and the amplitude are like how tall the wheel is and how far it is from the middle to the top. Neither of those things are going to change when we change the speed, right? Nothing physically about the wheel is going to change. So the frequency is related to the number of cycles this Ferris wheel makes. Remember, frequency measures how many cycles by the time we get to 2 pi. So our frequency is going to change with this.